A catapult launches a pumpkin at 45 meters per second at a 70-degree angle above the ground. How far away does it land from the place you shot it? So if I draw the problem, we've just got a basic sketch of a pumpkin being shot at 45 meters per second, and the angle here is 70 degrees. And its flight's going to look something kind of like this. So we end up with a nice curvy parabolic flight where the pumpkin spends just as much time going up as it does going down. So the first half of its flight is here, second half of its flight is there. Next, since the object's being launched at an angle, we've got to break it up into its horizontal and vertical velocities. So we use sine and cosine to take care of that. And when we do, we get the values 42 meters per second and 15 meters per second. So you have to ask yourself, was the pumpkin launched more in the upward direction, or was it launched more to the right? Well, it was launched more in the upward direction. 70 degrees is a very sharp angle, which means your original velocity in the y direction, your initial velocity was 42, and in the x direction, horizontally, your initial velocity was 15 meters per second. Next up, we set up our YTX chart, and we throw in all the information that we know from the problem so far. Now remember, our biggest goal in this problem, the most important step, is solving for time because that's what links everything together. And think back to our trick. If the thing was launched 42 meters per second in the upward direction, and every second it got 10 slower, then how much time did it take to peak? If it lost 10 every second and there was 42 vertical velocity to be lost, then the peak time would happen after 4.2 seconds of flight, which means the total time would be 8.4 seconds. We're already almost done. In the x direction, it was traveling 15 meters every second. But remember, gravity pulls down, it doesn't pull to the right. So this velocity in the x direction is actually constant. It just stays 15 meters per second through the entire flight. It's only in the y direction where the velocity changes. So if that's the case, then you're going 15 meters every second, and you do that for 8.4 seconds. If we multiply the two together, we get delta x equals 126 meters, which is more than a whole football field, so that's a pretty impressive shot. For this next one, a golf cart rolls off a building at 5 meters per second. If the cart lands 8 meters away, how high was the building that he drove off of? So if I make a quick sketch of the problem, we just got our guy in the golf cart going 5 meters per second straight to the right, and then he ends up landing 8 meters to the right of the building, and we want to know how tall it was. So this problem's the same business as usual. We make our YTX chart, and we start filling out the information we know to find the information we don't. So from the problem, I was able to gather that his initial velocity in the x direction was 5 meters per second, and he traveled 8 meters to the right, so delta x was 8. In the y direction, we were hardly given any information at all, but we do know his initial velocity was 0 because he wasn't driving up or down or anything like that. He was just going horizontally off the cliff. And we always know that acceleration is minus 10 in the y direction. This problem is actually a little different from the other ones because we don't have enough information to figure out how much time he was in the air. They didn't tell us how high the cliff was. That's what we're looking for. We actually have to start with the x direction. So check this out. If he went 5 meters to the right every second, and remember his velocity in the x direction is constant because gravity pulls down. You only have an acceleration over here. So if he went 5 meters per second to the right, and he traveled a total of 8 meters, we can calculate how much time he was in the air over here. If he traveled 5 meters to the right every second and he went 8 meters, you get a time of 1.6 seconds that he's in the air. Now it's the same process as before, we're just going backwards. We found time, so now we shuttle it to the other side of the chart in order to figure out how high this cliff was, or the building rather. As usual, delta y equals 1/2 at squared plus vit is going to do the trick for telling us how high this building was. And now that we have it, if we toss the values in, I get this. And finally, for the height of the building, we get that he fell 12.8 meters, which means the building was 12.8 meters tall.